My name is Richard. This will be the first in a series of tutorials on how to build your own drug discovery pipeline using Bash and Python. So, like our first project on StudentPharma, we'll be focusing with this project on trying to find a drug candidate for the TRKA receptor, which is involved in retinoblastoma, thyroid cancer, and many other cancers. So one of the databases I like to use, and this is the first thing that we will start with, is databases. I like to use Campbell. So, oops, I'll just Google Campbell. And I'll search up, oops, go to ligand search, and then we go to TRKA. So yeah, it has lots of cool stuff. You can even draw your ligand and whatever. And then I select targets, because TRKA is my target. Then I go and I see there's 4,399 different compounds tested. So let's check them out. This is all the info about the TRKA receptor. And then these are all the different tests that were done on it, and then all the info is uploaded here. So we want to get all this info. We want to get a file with it. So you see all these ligands, and basically you have all this info. For example, the type of thing they did, the molecular weight, the smiles, which is very useful, as we'll see. So we'll take the XLS data, and I'll explain why. Not the tab delimited, because it saves as a text file, and we don't want a text file, basically. So we'll go and we'll save this file. It's in the downloads right now. Okay, downloads is ready. So I already had it downloaded here, so I'll just grab this, copy it, go to my desktop, and then I'll put it here, temp tutorial. Okay, so I have this here, but we're going to be working with Python and Bash, and it's a lot easier to work in Python with a CSV file. Comma separated value file, which is like an Excel file, just in a different format. So as you can see, this file has all the same information we saw online before, molecular weight, A log P. That stuff we can save. We want to remove the columns we don't want, and we want to remove some columns lack data, as we'll see. So let's save it as a CSV file so we can work with it. We'll do uncurated ligand list.csv. Alright, so that's saved. Alright, so close that. Okay, so we have it here. Now we need to make a Python file to work with this. So I'll open this in terminal. So just a quick break from this. I'm working in Linux on Ubuntu. I'm using Python 3. Mac users should be able to do this stuff from their terminal. Windows users have to install a virtual machine or dual boot. So I'm going to open this in terminal, and then I will, actually I won't open it in terminal, but we'll need the terminal for after. I like to use Sublime Text. There's many different text editors or IDEs you can use for this. So I'll just close all my shit here. So I'll do a new file. I'll save it. And I'll go to temp tutorial, and I'll save it as CSV cleaner.py. So this is, anytime you save a Python file, you have to save it as .py. So our first step is Python needs different libraries to work with. So we're going to be working with CSV files, so we want to import the library that we need for that. So we'll do import CSV. Now we want to go through this, so I'll open up the file so you guys can see. Yeah, so we want to have tab selected as our delimiter. Even though it's a CSV file, it still is separated by tabs. For some reason, this is how it works with the files we get from this database. If you save it with commas, it gets very messy, unless someone finds a better way, which would be great. So we want to save the stuff we're interested in. We want to know the ligand name. These are all the ligands for the TRKA receptor. We want to know the molecular weight, the A log P, the PSA. These are molecular descriptors, and they can be useful in softwares like KNIME. So once we process this data, we really want to keep the important stuff. SMILES is like the structure. So basically, as you guys can see, if you've done any organic chemistry, it corresponds to an organic structure. Then you have standard type and standard value. So these are the different experiments done to find out these different things. The residual activity, Ki, EC50, all basic pharmacological assays. And then you have the values that they get in nanomolar or percentage, and yeah. So we want stuff that has KIs of like very low KIs. We want like under 10 KI, because that will be something with a 3000 KI is not a great drug candidate. It's going to go off target. It's not ideal. We want something with like an IC50 of 1 nanomolar, just stuff with low values. So this is saved. What do we want to keep? We want to keep these. We want to keep this. We want to keep this. And published type, standard type, because the published type is different from the standard type, because this is what they actually published, and then someone had to standardize it. It's pKi, and it's not always in nanomolar, sometimes it's in micromolar, so you want to have it all converted and standardized. So we go to our Python file, and we'll open the file. So we'll do with open uncurated ligand list.csv, and we have to put it, so we want to write it as a string. A string in Python is a sequence of characters, basically. It needs to be between parentheses. So we're telling the program we want to open this file, and then we do R, which means we want to open it in read mode. If you open it in write mode, it'll overwrite the file and create a new file with that name in its place, and it'll be empty. So we don't want to do that. And then we do as F. So we open this file as F. That's what our file is called. It's an object right now. Now we want to go through each line of, right now we want to go, first of all, we want to go through the first line of the CSV file, and we want to grab whatever column headers that we care about, because we want to make a new CSV file that will have all this stuff cleaned up. So first we'll actually open another CSV file, and this one we'll be writing to, and we'll call it curated ligand list.csv, and we'll open it in write mode, so W, and we'll open it as C. Then we have to create objects from these files, reader or writer objects. So I'll say reader equals csv.reader. So CSV, again, it's a library, and it has these functions in it. So csv.reader calls on the reader function. When you do that period between CSV and reader, you're calling on that function. And you do CSV reader, and you do it on F. And writer will be csv.writer on C. So what we want to do is we want to grab the columns that we care about. So first we have to go through the before I go on. So you have to indent. If you indent, that means you're working within this this line. If you indent outside of it, you're not going to be working within the line. So if we want to work within these two, where these two objects, reader and writer, exist, we have to work within the line. So first thing we'll do we will loop through the file that we're reading. So the way that CSV files work is you have to go row by row. So we'll go for row in reader. So reader is our object. I'll just show you guys as an example. This is what your computer is going to read. If you print row, then you go to your terminal. So I'm using Python 3, so I'm going to write Python 3, and I'm going to write csv cleaner.py, So it just printed the entire CSV file. Not very nicely, but this is it. We really want to clean this up. Yeah. So it even ran out of space to print because it's not clean. Okay. So we wanna extract data from it. However, I think it's maybe not saved properly because it's printing the delimiters wrong. So if we can save it as uncurated ligand list, yes. Maybe we can go back to the Excel file, try to resave it. Delete these. So make sure we're using tab. Oh, I know what we did wrong. Okay. So, something I was missing. I'll just resave this file really quickly. So we'll call it uncurated ligand list. You can call it whatever you want. Save it again. Okay, it's saved. What we were missing was that we didn't tell our Python file to read this with, so we'll do delimiter equals tab, and then so we want to stay consistent in everything. Again, I'm doing this because when I did it with comma it was not functioning properly, but maybe if you do it a different way it will work. So see, right now we're getting the actual stuff, we're not getting the dash t's, so it's normal. So you get your ligand name, you get all this stuff, then you get all the numbers and everything. So these are all the different rows basically in that file. So we just printed the row. Now let's say we only want to print the first row. We'll do break right after this, and if we run again, that's the first row. These are all the column headers. Okay, so now we want to extract only the column headers that we care about, and we want to add them to our new CSV file. So we will do so if so we have to go column by column in this row. So we only go through the first row, so we do for column in row. So we're going through the row right now, and the row acts like a list. So you can read up on Python lists if you don't know what it is. The first index of a list, so the first index of a list is 0. So if we go and we open this here, it acts like a list. So one row, this is index 0, this is index 1, 2, 3, 4. So we want to, in our file, we want to go for column in row. So we look at each index. We want to see if the index, so if Campbell ID, so what was it specifically that we wanted? CMPD Campbell ID. CMPD Campbell ID. Right, just to make sure. CMPD Campbell ID. If CMPD Campbell ID in, if it's in the column, then we want to write it. We want to save it. We want to know where it is. So we're going to make a counter. So we'll do a counter equals 0, and we'll do a ligand ID counter, which is equal to 0. So we'll, for each column in the row, we'll increment our counter. So this will, counter starts at 0 and it will keep incrementing. So if we do if CMPD Campbell ID in or do equals to column, then ligand ID counter equals counter minus 1. The minus 1 is because we're going through a list that starts at 0, so it offsets the counter. Then we look at what other column do we want. We want, we don't have to do molecular weight A log PSA, but if you want to, you can do it. You just follow the template. Honestly, what we care about is canonical smiles, and yeah, and then maybe the standard type and standard value. So we'll do the same thing. We have to make some new counters. There's probably more efficient ways to do this. This is just so you get a good understanding of how to do it. So smile counter. So smile is it's a type of format for the chemical structure. So we'll do if smile equals to colon, then smile counter equals counter minus 1. And you guys will understand once I get through this why I'm doing this. So if standard type equals to column, so that's another column we want to grab. That's this guy, standard type and standard value. These are the numbers we're going to be working with. We want to clean up our table, so same thing. So we have to make a counter, so we can make a standard type counter equals 0 and standard value counter equals 0. So if standard type equals column, then standard type counter equals counter minus 1. And I think we can copy and paste, yeah. If standard value is equal to column, then you can do standard value counter is equal to counter minus 1. Now, so we have all these locations. We'll know where it is. Again, so this code will only work for this Excel file that we have. If we have another Excel file that had different column headers, like if this was called just ligand ID, then we would be looking at different strings. We're not looking for CMPD. We would try to look for, so it's a bit hard coded. It's hard to make this robust just because the databases all have different ways of doing it. So we'll do this. And then we will do column in row. Okay. Yeah. Then we will, so break means we only go through the first row. Then at this moment we will do writer dot write row, and we'll only want to add the columns we care about. So we're writing one row with certain columns, and we'll do row, and we'll do ligand ID. So the row is a list, and ligand ID counter is an index in the list. So let's say ligand ID counter ends up being 0. That means we're going to the row in our uncurated ligand list. We're picking 0, and we're writing this index. We're writing that string to our curated ligand list file. So we go writer dot write row. Then we will do smile counter. So then our next column will be our smiles. Then we do writer dot write. Actually, so we're writing only one row, and the row has to have multiple columns, right? So we'll just add all of these guys. And we'll go to standard value counter. Okay, so we have everything we want in our row. We have all the columns. We'll run our file. So we're writing python 3 csv cleaner.py, and we press enter. So we got a syntax error. Invalid syntax. Okay, so after your if statements, you always have to have a colon, not comma. So this should work now. Might still have some errors. Okay, and right row needs to have brackets around it because we're only writing one row. It's taking one argument, but we can have multiple, yeah, okay. So it just ran. We didn't get any error statements. So every time you run this, you create a new file called curated ligand list. And let's see what happens if we open it. Having a bit of lag. Okay, so it wants to open it, and it wrote CMPD Campbell ID here, so we have a problem here. That means the counters that we have are not working. I think Python has this problem where you can't do that. Okay, yeah, let's see if we got this fixed. So we have to reload the file. Okay. Yeah, and we still have a problem with the first one. Just figure that out really quickly. CMPD, MVID. Let's try canonical smiles. Maybe that's our problem. Yeah, oh, because I did equals. Okay. Because I did a direct equals statement. I can also do in. And now if we read it, yeah, we got our stuff. So this is the file that we wanted. Great. So again, like with any coding, there's always problems. So now we have our first headers. Now, so we've gotten out of this. We don't want to, I mean, we can keep writing, yeah. So we break the column in each row, and then we want to copy basically the smiles and the standard values, and we want to copy the standard types and the ligand IDs now from our uncurated ligand list. So we're still going row by row in the reader. We've stopped going column by column. So now we go into the reader and we say writer dot write row. So this will start the next row in the actually, I think we might have to keep looping. We might have to restart looping. Yeah, have to restart looping through the reader because we did the break statement. So then we do writer.write row. We want to do row, and we want to copy this. Okay. So let's see what happens. We have a problem. Okay, we did one too many rows. Okay. Okay. Let's see. Yeah. So you get your you get your ligand ID, you get your smiles, you get your standard type, and you get your standard value. Now, we don't really care about KIs of 2511. We want to toss these guys out. So, we'll put in another step of cleaning, basically, into our file. So we'll go back into our text file, or our Python file with our text editor. Okay, so for row and reader, we'll write the row, but we'll only write the row if. So we want to put some statements. If row, and we'll check the standard type for so if row standard type counter, so we want to access that index, is actually we can do it here. So if the row at the index of standard type counter is IC50, or, and we'll copy this, KD or EC50 or KI. So these are the different types of assays that I would be interested in. Maybe you can look at percentage inhibition, but or residual activity. I'm not sure if we want to really look at that. Maybe it's useful. There you would have to recalculate it into a KI of some sort, and it just complicates things. So we really only want IC50s, EC50s, and there is a shit ton of, as you can see, IC50 assays. So we keep that. So right now we're only taking if the row at that index has an IC50, we'll take it. So that's our first condition. Then we'll write the row. Then we only want stuff with IC50s or KDs or EC50s or KIs under 10 nanomolar. So we say if row standard value counter. So we look at the this index here. Sorry, this is the standard value. That was the published value. Just scroll over. Excel is very hard with a touchpad. Okay. So standard value, we only want the guys under 10 nanomolar. You can look this up online. People say under 100 nanomolar, it's not really, it's hard to use it as a ligand. It's going to have off-target effects. We don't care about the other ones. So we'll do if row standard value counter. So at that index, if the row is under 10, and we'll have to, so 10 is a number, right? So we'll have to make this a number because when it reads from the CSV file, it reads as a word. The different can read about different variable types, or if you understand basic Python, you have floats, you have doubles, ints. You want to convert it to a float. But before that, sometimes there is no value, and Python can bug out. So you want to add another conditional statement, and I promise this is the last one, I think. You'll do if row standard value counter is not, so that means it's not empty, then you can work with it. And I also forgot my colon here and here. So always at the end of an if statement, at the end of a loop, you have to put your colons in Python. So then if this is what it is, then we'll write the row. So we have an error, invalid syntax. Okay, this can take a while to fix. This is probably a question of, okay, there's no or statement. So you have to write your or statements. Yeah. Okay. So you can write and or. These are all logical things. You can Google this for Python. So, and it ran. Okay, great. So let's check our curated ligand list. Okay, it's already open, so we have to close it and reopen it, I think. Let's close it and reopen. Alright, let's see what we got. Okay, great. So our standard values, as you can see, we don't have any values over 10, which is great. So we've isolated only IC50 assays, KDs, KIs. We have everything we want, really. You can keep your molecular weight, you can keep your A-log, your PSA, all the other shit you want from the original uncurated. But right now, we have our curated sort of database, and I'll stop this first tutorial here, and I'll see you guys in the second part.